Okay, guys, good morning again. Welcome back. And sorry to get the stream started just a little closer to the 9 o'clock hour today. But anyway, we have a few seconds and then I'll get things started. Good to be with you guys. Feel free to say hi or anything in the chat whenever you like. Hey, Ryan. Okay, guys, so now that it's pretty much 9 a.m., I'm going to get things rolling. Hi there, everybody. Good to see you again. Today, the plan is to wrap up the last few leftover notes from the article by Ted Sider on time. And then after that, we'll try to finish this whole topic up by switching to the last author, which is David Lewis, and looking at his paper called The Paradoxes of Time Travel. So hopefully today we can wrap up the time unit, and then we'll get started on philosophy of mind on Friday. But as usual, thanks again to everyone for being here. Appreciate all your work and focus on the class, and I hope things are going well in your other classes too. So let me just try to bring us back up to speed with the last lecture, and then we'll continue from there. When we were here on Monday last time, we talked about Ted Sider's article Time, and this is following along on our earlier lectures on the same topic. So essentially, Einstein kind of changed the way that we think about time and space by advancing the theory of relativity. And on the basis of at least one simple thought experiment, he's able to demonstrate that the concept of two events being simultaneous is relative and it's not absolute. He gives the case of two lightning strikes happening at separate positions along a railroad track. And he says, suppose they happen simultaneous. What does that mean? He says, well, we really have to be able to form a test that could be used to determine whether the two events were simultaneous or not. So what kind of test could that be? He says, all right, well, measure the distance between A and B, the two positions, designate the midpoint, place an observer standing at that midpoint motionless, and if this person sees the two events from that position happening at once in their field of vision, then relative to them, they would be simultaneous as long as we assume that the speed of light is always constant, such that the two arriving rays of light from the two distant points have traveled the same speed and have covered the same distance, reaching the endpoint at the same moment they must have left from their two origin points at the same time. But if we consider a second observer on the scene who's passing through the train tracks in the direction of travel towards B and away from A, if they surpass the midpoint M prime at the same moment that the other individual conducts their observation, then unlike the first motionless observer, they will not see the two events happening at once, because given their state of motion and velocity, they're going to be carried to the right towards event B, and therefore the light signal from that event has a less distance to travel to meet their eyes than the other one that's running on along from A. So in the order of the experience of the second observer, they're not simultaneous. B is first, A is second. If there was a third observer, they would see the events in the opposite order if they were going in the opposite direction as they surpass the midpoint going towards A. Okay, so after this, we described the twins paradox, time dilation, light clock stuff, and that just kind of filled in our conceptual understanding of the Einstein. Afterwards, we started looking at the philosopher Ted Sider's paper called Time, and we just have a few things left over with his paper to finish this morning. So what about Ted Sider? Okay, he starts the paper off by saying that it's actually quite hard to understand time when you start to think about it in any kind of depth, because very basic concepts of it that we take for granted are hard to explain. One thing is that everyone says time moves. Time is flying, time is passing, time is marching on, time is flowing. So these are all cliche phrases which express the general idea that time moves. And, well, that's hard to explain. What does it mean to say that time moves? Because the reason that's not so easy to explain is because motion itself refers to time in its own definition. So if I say that something has moved from one position to another, what happened? Well, it was at different places at different times. So if motion is an object being at different places at different times, then the analysis of time moving, if it was on similar grounds, would be this saying that time is at different places at different times, and that's how it moves. But now we've utilized the concept of time to try and provide a definition of its movement, and that's giving us a circular definition. He explains this even further with the diagram shown of a train that moves from its initial position in the station at Boston all the way to its final destination in DC. And in the graph, which we displayed last time, we show its movement by positioning it at different destinations at different times in the sequence of events from where it started to where it ended. So again, that just shows us that for an object to move, it has to alter its position at different times. And it seems that that invites a circular definition with an infinite regress if we use time in the same analysis. He says another attempt to try and explain this would be to say, okay, maybe time moves by the present moment moving. And a separate graph was drawn to try and explain this concept. In the graph, we had these 4 horizontal lines with 4 time indications to the left of each one. And we tried to show the present moment moving by being initially at 12 noon, a second separate time later at 3 p.m., subsequent to that 6 p.m., and then after that 9 p.m. The problem here, though, is that the 4 time coordinates to the left of the graph are themselves time-like dimensions, t1 through 4. And if those have some kind of linear sequencing, then they, according to the analysis given, would have to be positioned within a broader graph of a higher order sense of time, which again invites an infinite regress. So in the end, Sider said the best way to avoid all these puzzling problems is to completely abandon the notion that time moves at all and rather embrace the theory of space-time from Einstein, because according to that theory, time does not move. All the events of space-time are equally real, and they all exist in the big structure of the universe. So according to that view, nothing starts happening, stops happening, time isn't passing or moving in any way. It's just a big container jointly holding all the events in tandem with space, which it's integrated with. Now, how do we reconsider the way we think of objects and even people like us according to the space-time theory? That led us to the space-time diagrams that we were showing last time. In a space-time diagram, we see the existence of an object not just in terms of its spatial dimensions, but there's also a temporal dimension, a time dimension, and on the graph, the duration of the object is shown by how long it extends along that dimension. And we mentioned also that according to the space-time theory, objects like us, and every object really, have got both spatial and temporal parts. Does anybody remember what's a temporal part? Let me know if you can tell me that, just to check in with you for just a moment here. So what is a temporal part of an object according to the philosophy we learned? A temporal part, what is that? Yes, it's an object at a single moment in time. So each second, well, I shouldn't even say second, because time can be obviously divided further down than just 1 second. There's half seconds, milliseconds, nanoseconds. But the point is that for every single individual instant of time, each moment, there's one temporal part of a given object. And the whole object is the aggregate set of all of its temporal parts collected together as one. Now, at each moment, you only experience one of the temporal parts at a given time. Like, for example, as you watch this lecture right now, one temporal part is experiencing this part, but a different temporal part is experiencing this part, because time keeps rolling forward, or I don't know if I should say rolling forward, but the space-time structure is segmented into parts. So for each additional moment of time, there's a different temporal part of you. On that view, you're never fully present in one given moment. Like for me, for example, right now lecturing to you, there's just a few of my temporal parts, the ones that occupy that part of the timeline between 9 and 9:50 on this given date. But you've not been experienced with my temporal parts from before the semester, or the ones that I guess will happen afterwards, and same with you. Now, the next part, and one of the last things in the paper he had, was this. So if we're supposed to now at least entertain the possibility of the space-time theory as a way of evading the difficulty of saying how time moves, then let's try and be even more clear about how time and space are similar according to the theory. So 3 similarities between space and time according to the space-time theory. This is what Ted Sider wants us to think about next. So I believe I closed with this. 3 similarities between space and time as according to the space-time theory that he's discussing. Okay, So the three big similarities were, number one, in terms of reality. Okay, number two was in terms of parts. And then third was in terms of the words here and now. So these were three things that have not yet been covered, and I want to go over them now. So let's start with that top one. It says, in terms of reality, that's one similarity between time and space, in terms of reality. So what it means is this. Objects that are far away in space are just as real as objects that are close up to you in space. So distance does not affect reality. Like this marker that's right here in front of me, it's real, but it's still real when it's a little further away. When it's even further away, it's still real. Now, what if I leave the marker here and I create some more distance between it and me? Sorry. So I leave the room, marker stays here. It's still real, even if I'm a mile away from it, 10 miles away from it. How far can I go away from it and it still exists? I mean, it doesn't matter. I could send this thing to the moon, outside the Milky Way galaxy. No matter how far it goes away from me, it's not like it crosses a boundary where now it's not a real object. So things that are right up in front of you are just as real as the moon, which is far away. And that's just as real as things that are even further away. So objects, in terms of how spatially distant they are from an observer, they're just as real. And the same is true of time, according to this stated similarity. So let me write that, and then I'll explain it a little more. So objects far away in space are just as real as objects that are close up in space. Okay, the same is true of time. Okay, so what's claimed here is this. There's distance in terms of space, but we also sometimes talk about distance, temporal distance, how far away in time something is. So like when you talk about sometimes things in the past, you use phrases like, oh, remember back then, back in the day when I was a kid or something, I remember way back. When talking about back, it sounds like a spatial metaphor, like back behind me in space, way back there behind me, some events happened that I can remember. And sometimes when you talk about the future, you also use spatial metaphors. You say, oh, what lies ahead in my future? You know, what is out ahead in my life, way out in the future for me to experience. So whether you're talking about something way out far in the future, something way back in the past, the claim here is that those events are just as real as this present moment is. So right now, this is real. This is obviously the present. You guys are having this lecture happen, and I'm teaching it, and you're attending it. But you might be thinking right now that there's actually no reality to the past or the future, that there's just the now. There's only the present. Well, you have to let that idea go if you want to embrace the space-time theory, because according to it, you as a little child or baby, in high school and middle school and K through 12, those different parts of you in time are just as real as you sitting here right now as a Chapman student watching this lecture. And you, let's say in the future, being a grandparent, starting a business, graduating college, traveling the world, doing things you haven't yet done, all those future parts of you that are out ahead are also just as real as this moment right now. So spatial distance doesn't change how real something is. A marker that's in front of me is just as real as if I fire it away towards the moon and it's millions of miles away from me. And the same is claimed here about events in time. So distance in time does not change how real something is. According to the space-time theory, it's all real. The future, past, and present all equally exist, and there's no priority given to the present. It's not like the present is somehow special and privileged, and it's different from the past and the future. So those past and future moments, all the moments for all objects and events are equally real. You kind of comprehend that? So My hand is just as real as the moon. The moon is much farther away than my hand. And you don't doubt that when it comes to space. You don't think that there's some distance in space that converts something from being a real object to just not existent. And the claim is that temporal distance doesn't affect how real something is either. So it's all out there. All the events are real, not just in terms of how distant they are in space, but also in time. That doesn't affect how real they are. Okay, now the second one here is in terms of parts. And sorry for the glare, but it does say here in terms of parts. So that's the phrase right there. What it means is this: objects occupy space by having those spatial parts that we've talked about. Like in your case and my case, our spatial parts are just our body parts, like our arms, legs, hands, torso, head, whatever. So objects occupy space by having those spatial parts. And in similar manner, objects occupy time by having temporal parts, and they're both equally real. So here we go. They take up space by having spatial parts. Those are just physical parts of the object. And objects occupy time or take up time by having the temporal parts. Okay, so we're trying to advance a more accurate understanding of time by comparing it to things that we already understand about space. We know that in space, when objects are far away, they remain real. And in the same sense, events that are far away in time along the same lines remain just as real as the things happening now. So things that are present in space are not the only real things, and moments that are present in time are not the only real moments. And in this case, we're talking about the similarity in terms of parts. So objects in space have parts. Like, a table has table legs, the tabletop. A car has the wheels, the interior cabin, the hood, the trunk. A human body has the parts of the body that we all are familiar with, which I've mentioned. So objects occupy space by having those parts. Sitting in the chair that you're in right now, the mass of your body is taking up some space that other things can't occupy because the parts of your body hold that space. They occlude other things from taking it up. And in the same sense, objects occupy time, according to this SpaceTime theory, by having temporal parts. So the way that things endure through time and they last for more than just an instant is by having a series of temporal parts that are linked together in that time sequence. And the way that objects occupy space by taking up a volume of space is by having spatial parts. So whether it's spatial parts or temporal parts, both parts are real things that exist. And according to space-time theory, we're supposed to consider those temporal parts to be just as real as the spatial body parts. So if you look at your right hand and you agree that it exists, and you have no doubt about that, space-time theory is asking you to have the same type of total confidence that temporal parts of you lying in the either future or past are just as much real. They're not just figments of philosophy or science. They're just as real as the body parts that you have. Okay, so objects take up time by having temporal parts, just as objects take up space by having spatial parts. And then the third one here is in terms of the words here and now. How are those things similar, and how do they show similarity between time and space? Okay, well, in this case, the idea is that both of them are relative terms. So their meaning depends on the context of the speaker. Okay, so both are relative terms, meaning that they don't have any absolute meaning. Their meaning depends on context. It depends on the context of the speaker. Okay, so they're both relative terms. Here is a spatial relative term, and now is a temporal relative term. So let's think about that, and let me ask you guys a quick question. Where is here? Where is the place that's referred to by the word here? Can you tell me? Is there one objective location that we all point to on the map and say that is the place everyone calls here, or not? What would be your best stab at telling me what the word here refers to? What place, what position in space does here designate? The word here, H-E-R-E. Where is here? Can you tell me that? It's kind of a trick question, but I think if you can just contemplate it for a moment, you'll be able to give a reasonable answer. Okay, so Alex, you say current location. Yes, that's fair. Drew, you say where you are at the moment. Okay, also good. Ellie, the place that the speaker is. That's very sharp and precise. Yes. So let me say that's basically all correct. The way you've put it, Ellie, is very good. The location of here is not an objective place. It's relative, isn't it? It's relative to wherever the speaker is when they say the word here. So like if I say to you guys right now, here, the governor is Gavin Newsom, then I'm saying something true. But if I'm talking to someone in New York, and they're going to say here the governor is Andrew Cuomo, and so it sounds like we're contradicting each other. How can here have two different governors? Well, it's because here doesn't refer to the same location. When I'm speaking on the West Coast here in California, the statement here refers to the surrounding area and the environment where I am speaking, where I'm situated. So my speech act and utterance of here doesn't refer to New York. It refers to California because that's where I'm physically located. And in the speech act of the other person, when they say here we have Governor Cuomo, that's also true because here doesn't refer to one standard location. It just refers to the relative position of the speaker that speaks. So if I told someone on the phone, hey, it's really cold here, and they're on a hot location where it's really warm, and they say, oh no, here it's really hot, we're not disagreeing with each other because we're referring to two different places given our different locations where we're speaking at. Okay, so understand that. There's not like, if you look on a globe, not like you're going to see a place pointed out with the name here, obviously. On the other hand, what about now? When is now? When is the time referred to by the word now? When is now? What time of day is now? Or what can you say about that? It's very similar now to the concept of here, so that's already helping you, I think, to give the answer. What do you think about the time of now? When is now? What do you think? When is now? Okay, good, Alex. The current moment that the speaker is experiencing. So, again, then now does not refer to one uniform standard time. It refers to whatever time a speaker speaks at. So if I say to you guys, now we are learning about Ted Sider's article of time. I'm referring to the time spoken at. So I just said that at 9:22 a.m. on April 14th of 2021. But if there were people 100 years ago studying Einstein's work in universities, and they said, okay, everyone, let's open our books now. Now is the time of the semester where we will study Einstein. They were not referring to 2021 because obviously those are temporal parts of people speaking 100 years past. And so their reference to the word now referred to the time and date spoken at that time. And if, let's suppose, there are human beings in 100 years from now that are talking about the 21st century, and they're like, wow, was it a crazy time 100 years ago with the pandemic and the explosion of social media and everything. It's a fascinating historical time period. Now let's look back and study it. Those future historians, which use the word now in their time, would not be referring to 2021, but again, whatever time it is or date it is at which they speak. So now, as with here, doesn't have some kind of objective position in time. It's relative. And that is surprising to some because when you think about the word now, oftentimes you think it has an objective significance. Like this right now is the only now moment, and all the other times are not present moments. But the SpaceTime theory claims that relative to the speaker's act of speech, all moments are relatively the moment now. Given a context of speech, we can assign now to any different point in time and space. So it doesn't have the kind of objective and privileged meaning that you might have thought. Future people speaking the word now also have access to the present, but relative to their speech act, and in the past, the same. Okay, so those are three similarities between time and space. To understand these similarities will bring you into a deeper comprehension of really what is being stated and claimed in these theories of relativity from Einstein. The physical and philosophical implications of it are basically these implications here. Now, after saying this, Ted Sider returns to his main theme, which is this a better way of thinking about time and space than the old school way we thought about it, where there's only one moment now, the future and the past don't quite exist yet, and that moments that are distant from the present are not real. The common sense, what's called presentist view of reality. Our ordinary conception of reality is what philosophers and some physicists call presentism, which means that there's just the present moment, and the other moments are all either in the future and undefined, or in the past and forever gone. But the Einstein space-time theory replaces presentism with what's called eternalism. So all moments are eternally real. Nothing happens to any of them. They've always all been there. They always will all be there. And so we have to then discard the notion of time passing or events coming into being and passing out of being. So does time flow like the common sense idea of presentism, or is it really more like space, where it just sits there and holds everything? The space-time theory avoids problems with accounting for the flow of time. That's why Sider thinks it's better. But it does strike some people as counterintuitive, obviously, because it's quite weird, isn't it, this space-time idea? Some people might disagree with him and insist that that cannot be correct. Let me read a quote if I can. And he says, here's what some people that can't accept this stuff might say back. A person may say, past and future objects do not exist. The past is gone, the future is yet to be. Things do not have temporal parts. At any given time, the whole object is present, not just a temporal part of it. There are no past or future parts left out. Now is not like here. The present moment is special, unlike the relative piece of space around you when you say the word here. So these kind of intuitive criticisms of the view, I think they're oftentimes given by philosophers and laypersons rather than scientists and physicists, because this is pretty well accepted as a consensus view within advanced cutting-edge physics. But, they are philosophical puzzles, and they're problematic to just grapple with conceptually. Another issue that some might raise with respect to the space-time idea, if we're looking at objections, would be that according to the space-time theory, nothing changes ever. And for some, that might seem to be a bridge too far to accept. Let me write that down, and let's just quickly talk about it, and then we'll be pretty much done with the Ted Sider. So some people find this implausible and too much to accept, the idea that according to the space-time theory, nothing changes. And some people find that to be implausible. Okay, so let's try and grapple with this heady idea that nothing changes according to the space-time theory. Well, why would you think so, according to your current understanding of the idea? Let me give you an example to think about. Suppose that a person has like long hair, and then they want to really change up their look, so they cut the hair and it's very short afterward. Now, an ordinary way of looking at that might be this statement. Their appearance has changed. They've changed their look. They had long hair, now it's short. On the space-time theory, though, nothing has actually changed. There's been no real change. Why do you think it is that on the space-time theory, these events that we've described, the haircut, for example, it's not actually anything changing? Why would you say that that makes sense according to the theory anyway? That although we say that the person's look has changed, metaphysically speaking, according to the parameters of this idea, there has not actually been anything that has changed. Why would you say that nothing has changed if you follow the space-time theory? What could be the answer? The before and the after, it looks like there's long and then short hair. That appears to be a change, but why would it not be described properly as a change? Okay, Dimitri, you say the spatial particles of long hair still exist somewhere in space-time. Well, you're using the word space. I think that you're close, but you have to change the way you've said that. What is it that remains throughout all of space-time in the existence of an object? You're kind of close, Dimitri, but maybe you want to try and restate it or reformulate that just a bit. Or anyone else, if you think you've got the idea. The person has had a haircut. but nothing has changed. And why is that? There is something to say, Dimitri, correct, about the long hair part of the individual still exists. But I'm just trying to get you to use the proper terminology. What is it in terms of space-time theory that we say still exists with respect to the long-haired part of the individual's overall career of time? Nicole, you say the temporal parts of the long-haired person still exist. Correct. Only thing I would add to what you said, Nicole, is that they still exist in space-time. So space and time are integrated into one common structure. So that's the best way to put it. And Dimitri, you're pretty close. It was just that temporal part is what I was kind of trying to get you to add to that. So yes, on the space-time theory, let me show you this diagram again. Just a quick one. Here's the time axis, here's the vertical axis, and the horizontal axis. Person's born in 2003, like you, and then they die in 2100, like maybe you, and then, so they live, and I draw these like little stick figure shapes to show the passage of time as their timeline exists and endures, and eventually just terminates at 2100. Now, all of those temporal parts throughout the entire sequence of stages exist, and none of them starts existing or stops existing. They're just there in the space-time graph of reality. So the one temporal part prior to the haircut, let's say, is like this time slice. The next temporal part subsequent to the haircut with a shorter look is the next available time slice where you see that feature in the temporal part of the object. But look, the whole graph has just been there the whole time. The two different temporal parts adjacent to each other, one with the long, one with the short hair, they've always occupied their positions in the timeline of the series of events in the person's life. So there's not actually any real change. There's just what appears to be change because different temporal parts have different features. So is this like a fatal objection to the space-time theory? Does this make it impossible for people to grapple with or to accept? Sider thinks not really. He says, although it's a little weird at first to think that there's no real robust metaphysical change, we can still kind of re-describe change in a different vocabulary. We can say what people think of as one and the same thing changing is rather to say that different of its temporal parts exhibit different qualitative features. And that's what we call change. In the real metaphysical sense, nothing has changed. It's all been there the whole time. But we call it change because we see the different qualities expressed by different temporal parts of an object. So if I get like a black eye today, then afterwards you'll see the bruising and the discoloration on my face. The idea, though, would be that that temporal part of the space-time object that I am has always been sitting on that position in the timeline with the black eye. So it's not like that temporal part has undergone any change. It's remained consistent with its own features throughout whatever, all eternity, and it never will change. So one metaphor to explain this concept that I've seen, and I think it's used in the book, is the idea of a highway. So like take the case where you have a highway here, like a road, right, that people drive on. So I'm just trying to demonstrate the visual of what a road kind of looks like. Now suppose that as a person's driving along the road here, they notice that at the beginning, oh, it's so like messed up. The road is damaged. There's a lot of potholes, dips in the road, cracks in the cement. So it's a rough ride over here. Then you get to this part and it's all smooth sailing. It's very smooth and well paved, newly paved road. Now the person who drives along this path, they might say this. They might say, the road really changed. At the beginning of the road, it was so bumpy, but then as I continued driving, it got so clear and smooth. So the road really changed. But if you think about it, it's not necessarily that the road has changed. It's just that his experience of different parts of it has revealed different features of different parts of the road. But the whole road, let's suppose, the whole time, has had bumpy, cracky stuff over here and then smooth stuff over here. So the road as a whole hasn't changed, but in the order of his experience, he notices the qualitative differences between one segment of it and the others. So on analogy, you're the road in the space-time theory. You have all of the different features of each temporal part already set forth, and you kind of psychologically experience the order that they're revealed in by your mind. In the end, though, they're all equally real, including those that are either prior to or ahead of the moment of consciousness that you're presently experiencing. Okay, so that's what he says in order to try and justify that time and space are more similar than you would have thought according to the space-time theory. And that's also how he tries to push back against an objection. Yes, this future is already set for us according to the theory anyway, Drew. Um, there's alternatives to accepting the space-time theory, but it is a consensus position in modern science. So according to this view, there's really no such thing as an open future. I've really thought a lot about this. I wrote a paper I presented at a couple conferences where I tried to argue that we could still have free will, even if the future and the past are completely governed by the space-time concept. But it's a different way of thinking about free will than the ordinary way you think of it. When you think about free will, you believe that you can do anything, literally. Like right now, you have counterfactual possibilities open to you. But on the space-time theory, there's only one actual sequence of events that can exist because it's already determined and it's already there. So what is free will then? I think of free will kind of more along the lines of not being able to do counterfactually, to do otherwise, not to be able to do other than what you actually do, because I guess that would be impossible on this picture, but rather to have the awareness of why you're doing the thing. So I think that it's kind of an epistemic account of free will. When you understand why you are doing something, then I think you have a kind of greater freedom and dignity than like a leaf that's just blowing around in the wind. You and the leaf, I guess, are both governed by the physical forces of the universe according to the space-time theory and cannot do otherwise. But you, unlike the leaf, can be thinking about it all as it's happening. And so I think it is your consciousness and your subjective point of view on it that gives you a measure of free will. But it's a complicated debate, and it's a tough question. Anyway, though, I can't settle all those questions, those deep metaphysical questions that have been pondered for thousands of years just right now in a few moments. But those are my thoughts on it anyway. The last thing that Sider says at the end is that if space-time theory is correct, then what we should expect is for events to remain accessible, even if they were from the past or future. We talked about future time travel, which would be conceivable if an object could move much faster than other objects that stay at rest, because time would dilate so much for it that it would be able to access the relative future. Going into the past is a lot more difficult to conceptualize. They say that on the space-time theory, all the moments equally exist, so the past moments still remain in the universe. How to access them, it would require the bending of space and time in such a way that no human could probably survive it. People talk about the concept of wormholes and black holes and stuff, but you'd really turn into like a spaghetti noodle if you got anywhere close to one of those things. Anyway, though, thinking about the conceivability of backwards time travel is interesting, even if it's just for the purposes of theoretical considerations rather than practical ones. The author says that some well-thought-out time travel situations in science fiction can be logically coherent and consistent. So he thinks that it's not at least theoretically inconceivable. And that actually takes us into the next author. So it took a while, I guess, for me to finish up the last few points of Sider, but no problem. That helps us transition into the one more author on this topic, and that's David Lewis. Okay, so David Lewis, great American philosopher of the 20th century. He lived from, let me get his dates here, I think 1941 to 2001. Yes. So David Lewis, 1941 until 2001. He's one of my favorite in the modern era of philosophy. He's very creative, and he's written on all kinds of interesting topics. He takes on some of the weirder topics that some people are not as interested in, but I think he's earned a great reputation for that. He taught at Princeton, UCLA, in Australia for a significant time in his career also. And he has this skill in being able to defend sometimes pretty counterintuitive and weird theses with great clarity and skill. And this is yet another example of that. This is a paper that he wrote when he was still kind of young. It's called The Paradoxes of Time Travel. And it was originally given in 1971 as a lecture, but the version we're reading is the published version from 1976 when he was 35. So The Paradoxes of Time Travel, we'll say 1976. Oops, Paradoxes of Time Travel. 1976, David Lewis. Okay. Now, the thesis of his paper is actually, in a way, straightforward. He says time travel is theoretically possible. So his whole game is just to show and argue that, at least in theory, time travel is possible. It's not impossible. It's not logically contradictory. Some people think that there are aspects of time travel that appear to be paradoxes, and therefore they say it's not conceivable. But he says those weird, strange elements of the concept of time travel are just strange, but not literally impossible. So his goal is to defend the consistency of some possible time travel scenarios. First thing he wants to ask is this. Sorry, just my notification on my watch. What is time travel? What's the right definition of it? He starts us off with that question. So he says, here's the right definition. Time travel is a discrepancy between two different time frames or measurements of time. Okay. So some notes from Lewis's paper. What is it? So it is a discrepancy between two different time frames. Discrepancy meaning a difference. I'll say it this way, between two different measurements of time. And so he gives an example to help us think about this. So let's say that this person is the person that's going to enter into a vessel, and they walk into this vessel and it's like a big cylinder type thing. And let's say that when they walk in there, they get in and on their clock, it says that it's 1 p.m. Okay, so they get into this here machine at, according to their watch, 1 p.m. And they spend a total of 5 minutes in there according to their watch. So 5 minutes. When they emerge from the cylinder, here's the question I want to start off to make sure we're tracking this. When the guy gets out the cylinder, if his watch says 1:05 p.m. on the same day, then did he go into a time machine or no? So he got in at 1, he spent 5 minutes in there, and then he gets out. If he gets out and the watch just says 1:05, was that a time machine, yes or no? That's a yes or no for you. You understood? If he gets in at 1 and he spent 5 minutes in and then he gets out, it's 1:05, then no, it's not a time machine. In that case, did he travel through time? Not at all. He went into a shipping container and spent 5 minutes in there and then just got out. That's not time travel. Or if that is time travel, then I guess we're all time travelers, but in a very boring sense. We're all traveling from the past to the future at a constant, steady rate of 1 hour per hour. But that's not what we mean when we say time travel. We mean like jumping ahead or jumping back. So if this is actually a time machine, let's say that it's a future time travel scenario. Then if it's travel to the future, even though on his watch it showed that he spent 5 minutes in it, when he emerges, if this is a future time travel, then what should the watches on all external clocks say when he gets out? They should show some time that's later than 1:05, correct? So let's say that he does a short little bit of time travel, 2 hours into the future. Then even though he spent what was relative to himself 5 minutes in the machine, when he gets out, what should all the clocks say outside? Do you understand this question? So suppose he took a short 2-hour trip to the future, but he spent 5 minutes of personal time in the machine. Emerging from the machine, what should all the external clocks show? If this was 2 hours to the future travel. He entered at 1, spent 5 minutes according to his watch, but he travels 2 hours into the future relative to all others. So he should see as he emerges that they all show 3:05. That's correct, Ellie. The 2 hours additional to the 5 minutes of personal time that he spent in there. So what was 5 minutes of time for him in the machine is 2 hours for everyone else outside. And if he goes further into the future, like, I don't know, 6 months or something, then the date on the calendar that he sees when he gets out should be a date that's 6 months ahead of the date that's shown on his personal wristwatch that stays on his wrist. Okay, so that would be future time travel. Now, if this was time travel to the past, then when he gets out, his watch might say 1:05 p.m. because it's traveling with him, but all external clocks, things that are not inside the machine, should show a time that was prior to when he even got in. So that would be like getting out of the machine, and it's earlier than the time that you entered into it in the first place. Okay, so that's what it means by a discrepancy between two different measurements of time. Getting in and getting out, we can see that there's two different ways of answering this question. How much time was spent inside the machine? So one paradox might seem to be this paradox. How can the same two events be separated by two different intervals of time? That's the first paradox that he thinks he has to explain away. So first possible paradox. putting it like this, how can the same two events be separated by two different amounts of time? Some might say this does not seem possible. Okay, so here are the two events that are being specified are entering the machine and exiting the machine. Kind of like departure and arrival. You know, he departs, gets in the machine, arrives after having spent some time into a future time point or a past time point. Now, the reason that this seems like a paradox is, let's just ask. So suppose the guy got out, and like you said there, Ellie, all the external clocks now show 3:05 p.m. But on his own clock, because it's with him on his watch, on his wrist, it says 1:05 p.m. Now, here's a question. How much time is in between getting in and getting out of this machine? It looks like there's kind of two answers in a way. So what do you think? How much time is in between getting in and getting out of the machine? What's one answer? One way of looking at it is he gets in and then he gets out of it. How much later? See if you can give me that. So how much time is in between getting in and getting out? One way of looking at it is it's 5 minutes, right? Because he gets in there, and according to him anyway, it's like 5 minutes of time. He listens to like a couple songs on whatever Spotify, and he gets out. And so one way of looking at it is it's 5 minutes. But what if you're not the time traveler and you're just someone else that's looking at him getting in and then getting out later? To everybody else, it will seem as though he spent how much time in there? So, you know, to all the external clocks that are measuring the passage of time that are not on his wrist, it will appear to be 2 hours. That's right. So what's the answer? How much time is in between getting in and getting out? It looks like we have two answers. One answer is 5 minutes. The other is, well, I guess, yeah, 2 hours, 5 minutes, but not to be too picky. Fair enough, Drew. What's the right answer then? It looks like we have to give both, but that might seem impossible to some, right? You would think that if two events exist, they can only be separated by one duration of time. Like suppose that someone took a flight to California from New York. It was your friend or a relative. And when they land, you ask them, hey, how was the flight? They're like, it was a great flight. It was pretty smooth. You say, how long did the whole thing take? And they say, how long did it take? It took 90 minutes, and it also took 5 hours. So both. 90 minutes was the time it took, and it took 5 hours. You'd be like, are you losing your mind? I mean, I asked you how long it took. You can't give me two answers. Well, in this case, it looks like with the time travel situation, there would be two answers. Now, is this a paradox? Well, David Lewis says it actually is not so much a paradox once we introduce two different notions of time. So the way of getting around this supposed paradox is to refer to what's called personal time and external time. So two different time frames. So one, personal time. The other, external time. Now, what's personal time? Personal time is time as it is experienced by the individual time traveler as would be measured on the wristwatch that they keep on their body. So time as experienced and measured create a little more additional room here. But time as experienced by the individual time traveler as measured on their wristwatch. And external time, by comparison, would be time as it is measured and experienced by all external observers and clocks. So external and personal time. Now returning to the question here, how much time separates entering and exiting the machine, we have a more precise answer to give now. The right answer is to say that it was 5 minutes of what kind of time? Can anyone tell me this? 5 minutes of blank time, 2 hours of the other blank time. So it was 2 hours of which kind of time and 5 minutes of which kind? Now we have two types of time. We have two intervals. To which type of time does each interval correspond? The 5-minute interval corresponds to which type? The 2-hour interval corresponds to what other type? Tell me that. Personal time, 5 minutes, correct. External time on the measurement and observation of all other observers and watches, it would be 2 hours. Now, according to the space-time theory, we can totally have this result, that there are two different ways of measuring time, because on the space-time theory, each individual object in space, each observer, does have their own personal time. It's just that they all coincide on the planet Earth for the most part, because we can't achieve these type of variable speeds with the technology that we have. So for better or worse, I guess for better, we all occupy the same external and personal time. But if objects could accelerate much faster than others, as we have said, then personal and external time would diverge because of the phenomenon of time dilation. So there's actually no physical or theoretical impossibility here. In case there were forces that could achieve the effect of time travel, yes, there would be a difference between the measurement of time and the experience of time for the individual, and then the measurement and experience of time for all other external observers. So not actually a paradox. This is how the same two events can be separated by two unequal intervals of time, by distinguishing between the personal time and the external time. Okay, and there's a couple more paradoxes of time travel that the author talks about after this. So I'll have to probably push those into the Friday meeting, and we'll just cover them in about 15 minutes or so at the beginning. But other than that, we're wrapping up our time lectures, and we'll start with philosophy of mind on Friday. So do try to read the Meditation 6 by Descartes for Friday, and we'll go through it as carefully as we can starting then. But I guess for now, I'll have to let us all go because we're out of time for now. So let me know if everything's good, and if so, then I'll just close the stream and be back in touch on Friday. Okay, thanks so much, everybody. Take it easy. Really appreciate it. And if you need anything, as always, just let me know. But I'll see you on Friday. Okay, bye-bye.